It uses the same backend as the other stuff, so I'm not terribly hopeful, but we'll see. All right. So today I want to talk a little bit more about objects. Can I move it up? We'll start without doing anything just yet. So I want to talk a little bit about objects and some of these terminology around them. So one thing that gets quickly confusing for people when you start object-oriented programming is everybody has a name for every concept, and if you don't know the name, they look at you like you're stupid or something, but it's not the case at all. So just a few words that we should know. One of those words is class. So what's a class? It's difficult to say, right? What's that? A blueprint. A blueprint for a thing or a kind of thing. Not a really precise definition, but I think we know what it means. So, a kind of thing. A person is a kind of thing. Unfortunately, the word object itself, which is the word that is the title, in the name of object-oriented programming, has two meanings. So it has the meaning a kind of thing or class, but also a specific thing. Okay. So object is not a great word to use. The word instance is a better one, and it's this thing that means a specific thing. So we talk about classes, these kinds of things, the class person, the class the class musician, the class employee. And when we talk about an instance, we mean a specific person, a specific musician, or a specific employee. Inheritance is another big word. What does it mean in the context of objects? Yeah.
For an object to have access to a file, to have access to a value?
Sort of, but in a very specific way. Yeah.
Is it kind of like to receive copies from another object type deal?
Yeah, it's it's a bit of a circular definition. It's the way in which you can inherit properties, the way one object, the notion of one object inheriting properties from another.
So like sister class and stuff like that?
Yeah, so for example, a musician is a special kind of person, so anything you can do with a musician, or anything you can do with a person, you can do with a musician, apparently. So it's this weird notion that a class can inherit properties from another class. composition. So this has to do with access to properties as well, but in a different way. Does anybody know what that means?
Combination of two things.
Yeah, two or more things. So it's really the idea that an object or a class is the instances of a class. They're composed of different things. For example, a car is composed of wheels, steering wheel, handbrake, engine, panels, all of those things. So call this the notion that a class can be made up of other things. Okay. So if you think about a class, there's sort of two ways that it has properties or traits. It can either inherit them from its parent class, because it's just a special kind of its special type of its parent class, or it can just have some properties of its own. So it can have other things as properties. And there's these two phrases. Is a. And so that's when you're just using plain English and you say a musician is a person. And when you have that, when it seems natural to say that, that probably means that a musician inherits from a person. So one class inherits from another. So for example, and the related notion is has a. And again, you just think about using this in terms of plain English, how you speak plain English, and you might say a musician has an instrument. So it's a property that a musician has. It's not something that a musician inherits in particular or necessarily. It's just a property that a musician gets. And that's sort of where, so is related to inheritance, and has a is related to composition. So if you think of all of the things a musician has that are specific to being a musician, then that's what that musician would be made up of. So. Okay, and here's a big one, and this is one that people love to use because it makes them look smart and really scares off novices. Polymorphism. Anybody ever heard of this before? Yeah. Anybody want to offer a definition? Yeah.
Changing one thing into something else.
Not exactly. So poly means many in some sense, and morph. What does that mean? Not really, actually. It means shape, actually. So, so morph, for some reason, became used as a term for changing one shape into another. So they used the wrong part of the Latin or Greek to describe what a morph is, but it really means shape. So somehow it says a thing that can have many shapes. So really, though, what it means is, or what it refers to, is the ability to use different kinds of objects where some particular kind of object is expected. So for example, if I have a piece of code which works for any person, then that piece of code will also work if I give it a musician. It'll also work if I give it an employee. It'll also work if I give it a volunteer. I mean, name anything which qualifies as being a person, then you can use any of those things if all that's expected is a person. Okay. So let's say the notion that a general thing can be not replaced, substituted, let's say, by a specific thing. So if you expect a person, a student is okay too. Okay, so polymorphism is a word that they love to use in object-oriented programming, and it's unfortunate because it scares people. As soon as they hear it, they think it's some complicated thing that they don't understand, which is not true. Okay, so let's see if we can, so there's sort of the vague definitions of things. Let's see if we can put all of these together into and use them in some way. So let's go freestyling. So suppose we want to put an application together, and this application is, in some sense, to model a bookstore. Okay. And it's not to model a simulation of the people walking around a bookstore or the physical aspects or the shelves. It's really just to model the inventory. So things you find, well, here, let's put up some words and see where these things fit together. There's one word that certainly has to do with books, bookstores, is book. Author, novel, title, I don't know, subject, ISBN, thesis. Maybe it's an academic bookstore, so they have theses as well. Collection, like a collection of poetry, or a collection of short stories. maybe textbook. And important one is a publisher. Price. Editor. And let's say institution. Because some things don't have real publishers, they just come from an institution. So thesis is such an example. Okay, so there's a list of words that somehow are things that we want to represent in our system. And we'd like to organize these in some way using these concepts that we've just been looking at. Classes, inheritance, composition, is-a, and has-a. So, what are the classes here? Book seems like a good choice for a class. So, book. Maybe put it right there. What else? Yeah. Textbook. Certainly if book is a class, textbook seems to be a class too. What else? Collection. What else? What's that?
Yeah, because
Yeah, so let's think we're doing bookstore inventory, so
I think that's it then.
yeah. Well, there's one more I would put in there. Thesis. Okay. So we have book, textbook, novel, collection, thesis. And these other things, author, publisher, title, ISBN, subject, editor, price, and institution, they seem to fall into this other side of being properties of those other things. So now we want to identify some relationships. Is-a and has-a. It's usually important to identify the is-a relationships first. So, do you see any of those there? Yeah. Yeah. So each of these things, a textbook is a book, a novel is a book, a collection is a book, and a thesis is a book. So this suggests that there's this hierarchy here that all of these things are special kinds of books, so they should inherit from book. Okay. And I don't see any other is-a relationships among these classes. So textbook is not a novel, a thesis is not a novel, a collection is not a textbook, and so there doesn't seem to be anything there. A thesis could be part of a collection, in which case it would be an item in a collection. So that would be so that would mean the collection has a thesis in it. Yeah.
Well, isn't collection more of a group of books than an actual just book?
No, a collection. So I'm thinking of collections in like a collection of poetry or a collection of short stories, or In particular, not necessarily all having the same author.
Yeah.
You know. Okay, so now we want to start assigning these attributes to these classes here. So this is where we want to study has-a relationships. So what has a title?
All of them. Okay.
All of them. So all of these things have a title. And so since it's common to all of them, we'll put that under book. So we'll make that an attribute of books is having a title. What about a publisher? Yeah, pretty much all of them, or in the rare instances where a book doesn't have a publisher, you fake it and just make one up. How about an author? Is it? Yeah. So does every book have an author?
Someone wrote it.
Not really. Could be many people who wrote it.
I'd say a novel.
No. Even then, still multiple people can write it.
Yeah, but it's closer. It's a closer match. So I wouldn't say that all books have authors. A novel has an author, and a thesis has an author. A textbook, let's say, has an author or a list of authors. So really the only one that doesn't have an author is a collection. What does a collection typically have?
Authors.
An editor.
Yeah, an editor. So there's still someone in charge of making the collection, putting it together, and that's the editor. Get this out of the way. Okay, so what's left? We've got subject, ISBN, price, and institution. So what about ISBN?
Everything except the thesis.
Everything except a thesis. So that's kind of annoying. And so let's just pretend that everything has ISBNs. In fact, if this were a bookstore, a thesis wouldn't really be published unless it had an ISBN, unless there was a commercial version of it. Price. Everything has a price. This is a bookstore. It's the way of the world. Subject. All of them. It's not what I was thinking of, but you could argue that everything has a subject. But I was thinking about textbooks, so it would be the subject, the class that the textbook is intended for, the subject that the textbook is intended to teach.
Maybe a thesis that also has a subject, though, because it's
Yeah, maybe a thesis too. So maybe topic would have been well, we'd have the same problem. And an institution is what theses have. Okay. Good. So a book A textbook is a book, a novel is a book, a collection is a book, and a thesis is a book. And a book has a title, it has a publisher, it has an ISBN, it has a price. A textbook has an author and a subject, a novel has an author, a collection has an editor, and a thesis has an author, a subject, and an institution that it comes from. Great. So that's our lesson in object-oriented modeling. Now, and this is the kind of thing that people either do the way we've done here, in the sense that they do it very explicitly, or they think about while they're writing code, so they sort of do it in their head. But now let's see what happens when we turn this to code, or how we turn this to code. Okay, so we want to take this thing, so just a little bit more terminology. Object-oriented programming is full of it. This thing here are classes and the relationships between them, the ISA relationships between them. That's called our class hierarchy. It's typically drawn from top to bottom. Looks like what in computer science we call a tree, but you'd typically see a figure like this. Book, textbook, novel. It illustrates these relationships between classes. And starting at the top of the picture is the most general thing, which is a book. And as you go down like this, it's telling you that this thing, a textbook, is a special kind of book. Okay? So it denotes specialization. Okay. So what do we do in Python? So we create a class. Which class? Class book. What is the parent class of book? What's more general than book? Yeah. Object. There's nothing in our data that's more general than a book, so a book is just a kind of object. Object is the most general thing. And we've seen when you want to create a class, you need to have an init method. It always has to take this first, in fact, all of our methods have to take this first argument called self that represents the actual object that is being worked on. And what other arguments should our init method take? Yeah. And what should our init method do? What's that? Save them. So this is one of the hallmarks of object-oriented programming, is writing a lot of code that does stuff like this. Copying a bunch of parameters into what are called in different languages either instance variables or properties or traits. These things on the left hands of the assignment are the instance variables of a book, or its properties or its traits, and we just copy these parameters from a constructor. So common, in fact, that many IDEs have ways of just generating the code for doing this for you. Okay, So there's our book object. Any methods we'd like to add to this? Yeah, a nice one always for debugging is some method of converting it to a string that gives you something reasonable. Otherwise it becomes very difficult to debug things. So I don't know, maybe just something like just the title. Okay. What else? What's next on our to-do list? Yeah.
For the string function, it should give itself a credit.
Yes. Good catch. So what else? So you'll see that I constantly forget to put self here. That's because I have a long history of Java and C++ programming in which you don't need to do this. In Python, you have to be explicit about this. So what's next on our list of things to do?
Edit.
What's that?
You need to make it so we can edit them.
Well, interestingly, in Python, there is, well, first of all, it's not clear that we ever need to edit them because they show up on our shelf and they're created, and then I don't think any of these properties change over time, so it's not clear that we need to do that. But Python also doesn't stop you from just changing the values of an object's variables. Nothing against the rules there. What should we do next? Another class. Which class? So is textbook a word? Okay. I don't know. If it's a word, then we should spell it like this. If it's two words, we should spell it like this. Okay, let's say it's a word. And what is the parent class of textbook? Yeah. So textbook is a special kind of book, and so its parent class is book. That's what we read off of this class hierarchy diagram, saying that a textbook is a special kind of book. All right, so it's an object. It needs an init method. Well, just one brief digression here. So I won't talk explicitly very much about naming conventions in Python or other languages, but I will point you to, so you may wonder why sometimes I use capital names and sometimes there's underscores and lowercase or whatever. I'll point you to this because it's good for you to know. So Python people love to prescribe everything about writing code, even the stuff that could be done many different ways. So there is this standard Python style guide that talks about all sorts of conventions you should use in writing code. And one of the useful things to read in here, even if you don't ever plan on doing production strength Python code, is this little discussion of naming conventions. Because these show up in every language. So there's these various naming conventions, lowercase with underscores, and cap words. That's these things. So that's where if you have a name which is made up of a bunch of words, you capitalize the first letter of each one and stick them all together. It's also sometimes called camel case because the words end up looking a bit like camels. And so the two that are almost always used in Python are capitalized words for class names and lowercase with underscores for just about everything else. There's a few weird examples of things like global variables and constants that would use uppercase or uppercase with underscores, but we'll try and avoid those in this course. And here's a really, they're not shy about judgment, expressing judgment calls, for example. So this is a convention that's used in some languages, but they're happy to tell you that it's ugly. So don't use it. This is a nice read, by the way. If you want to know, does your Python code look nice, have a quick read of this thing, and you'll actually learn a lot. That carries over to a lot of other languages as well. Okay, so we want to write an init method for textbook. And, okay, it needs to take self as an argument. What else? So we want it to take author and subject. Is that all?
Yeah, we need all this stuff from the book as well.
Yeah, because if we want to create a new textbook, well, it's also supposed to have a title, a publisher, an ISBN, and a price. This is another hallmark of object-oriented programming.
The same thing over and over again.
Lines get doing the same thing over and over again. Sort of, yeah. So, okay, great. Now what do we do?
We need to only make author and subject.
So author and subject are somehow special for us. Okay. Terrific. We done? Is that it? Well, let's see. I think I've already got one up. Yep. Okay. Title, publisher, ISBN, price. ISBN, I don't know. Okay, so we can make books, and that seems to work fine. So let's try a textbook. So title, publisher, ISBN, and price. Some fake looking ISBN. And the other two things were author and subject. And what's the subject? Programming? I don't know, maybe computer science. Ah. So I try and print that, and it tells me that there's no attribute named title. Why not? Yep. Yeah, so here it is. It's an argument to this init method, but I never did anything with that argument. Yeah.
In Java, you pass it to the super, so I guess it's the same thing here, just different
Yeah, you need to call the books init method as well. And Java has a nice way of doing that. You just say super and list out the things. Here's how you do it in Python. Nice, eh? So this awkward syntax says get my parent class, the parent of this class, textbook, and call its init method with the arguments title, publisher, ISBN, and price. So the parent of this class is book, and it indeed takes those arguments, title, publisher, ISBN, and price. So so then that'll guarantee that all those other attributes, title, publisher, ISBN, and price, get initialized, get stored at the time this thing is created. Okay. And let's just do yeah. Okay. So someone said a hallmark of object-oriented programming is repetition. Not exactly. Here, for example, we saved the work of having to copy this this line of code. Instead, we just called these 4 lines of code. Instead, we just called the superclasses method. It's not such a big savings here, especially since it's so awkward to call super in Python. But once you do it a few times, you get used to it. But imagine that book was a more sophisticated class that had a lot more things that it needed to do, some of them which are quite difficult or tricky. You wouldn't want to have to duplicate that code in here. Okay. So, great. Let's do one more of these classes. Maybe we'll do novel, just to see how it works. Novel inherits from what? Book. And what are the arguments to novel's constructor? And what's the first thing we should do? Here's opportunity for a cut and paste error. What's the error that I just made? That's an error too. But don't forget to change the class name here, since we're in the novel class. Amazingly, that probably would have worked because novel and textbook both have the same superclass, but that's only by accident. Don't rely on that. And finally, we save the author. Okay, so now we've made this class hierarchy. Let's test it out. So let's make a novel. Anybody reading a good novel lately? Not a one? No. Yeah.
Dead House Gates by Steven Erikson.
Dead House Games?
Gates.
Dead House Gates. Steven Erikson. Publisher. Let's say Doubleday. ISBN, nobody knows those. They're almost useless now anyway. Price, author, subject. What about the price?
$13.
Oh, $13. Yeah, 13 sounds too even. Let's say. $13. Okay. Title, publisher, ISBN, price, author, subject. Title, publisher, ISBN, price. Author you said was Steven Erikson. And it's not a subject. That's it. Okay. Okay. So that seems to work. And let's make another one. Textbook we've done already. Okay. So this all seems to work now. So here's the big thing that people love so much about object-oriented programming, and the proponents say it's so great. It's this notion of polymorphism. So let's illustrate it now. So here I'm writing a method. I want to write a method that prints some information about a book. So let's print something. So what information can you print about a book?
You can print the title.
You can print the title. Books have titles. What else? Ah, yeah. Darn. Like this? No. Is that correct? What happens if I try this? And what will the error be? There'll be a name error. Title is undefined because title is a property of book. So I have to access it that way. What else can we print about books? Can we do that? It's not a part of book. ISBN. That's something books have. And in a bookstore, probably the price is pretty important. And then finally, we'll print a description. And that will be, so one way to get a description of a book is just to convert it to a string. Okay? All right. So there's this print book info thing that takes as argument a book and prints the title, the ISBN, the price, and then whatever happens when you convert that book to a string. So what happens if I print the book info for N, which is our novel? Okay. No surprises. You get the title, the ISBN, the price. What happens if I print book info for B, which is our textbook? You get similar information. So what's the big deal here? Why is polymorphism, I mean, what's the polymorphic aspect of this thing? No, I mean that's just what it does. But why would the term polymorphism be used to describe what's happening here? Yep.
It's because it can take any form of book.
Yeah. So I wrote a function which takes a book and uses only what I know about books. They have a title, they have an ISBN, they have a price, and they can convert themselves to strings. And later, I actually call that function. I never called it with a book. I called it with a novel, and I called it with a textbook, both of which are special kinds of books, but never with an actual book. So the poly part is from the fact that I'm able to call this function using different shapes of books, different kinds of books. And the morph is that they're different shapes. So, and now something that you may have missed is this last line. I print a description of the book. And that description I get by turning the book into a string. So what happens when you call string on an object? What's that?
Turns out like novel, not, and then it turns the info that you pull into.
Well, that's what happens when you call string on a novel. But in general, what's the general mechanism when you call string on an object? Yeah. It calls the object's underscore underscore string underscore underscore function. So here's that function for books. It prints book and then the title of the book. If we look at this, that didn't happen. It printed novel in this case, and it printed textbook in this case. Why? Well, that's because one of the books we gave it was a textbook, so it called this function instead. The other one was a novel, so it called this function instead. So somehow the language, it's not even difficult how, seems to know which is the right function to call. Okay, so this you sort of see it here. I called this function string book, and actually what gets called is a different function depending on what kind of book it is. And so that is the whole thing that people call polymorphism. It's nothing fancy. It's comprised of two things: the ability to take an argument which is a special case of what you're expecting, in the way that a novel and a textbook are special cases of book, and then combine that with the fact that if you call one of the methods that book has, it may actually not be calling the book's method. So it's not, we thought we were calling the book's string method, but that's not what gets called. what gets called is the method in the appropriate subclass, depending on which subclass we have here. Okay. So it's a small thing, but it turns out that it's very, very a very powerful thing. So it's something that you can simulate in other ways, even languages that are not necessarily object-oriented, but it's a really useful way of organizing flow of control in some sense. Okay. So it's clear to everyone what happened here. Okay. So we can do that with any. There's nothing special about underscore string. We can do that with any method name we want. It's not going to cause a problem. So, for example, we can add a method called prettyprint. So now we've got our novel and our book, our textbook rather. And if we look at what we just did with book, we defined a method called prettyprint that prints book. We defined a method called prettyprint inside of textbook that prints book but with more information. Probably should have had it print textbook, but let's leave that. And if we look inside of novel, there's actually no prettyprint method. So let's try printing our textbook. Print, prettyprint. Forgot to include the self argument. Again, that's because of my C and Java history. Okay, so we prettyprint this this textbook, and it gives us the title, the name, and what subject it is. So that looks like this method. How about now if we try and prettyprint this novel? What's going to happen? What's that? So one suggestion is that it won't work. Why not? So there's no prettyprint in the class novel.
It'll prettyprint it as if it's just a book.
Yeah. So there's no prettyprint in the class novel, but there is a prettyprint in the class book.
And because of the super class control about the novel, it's going to act as if it's just a book. So that prettyprint is like that.
Yeah. So the subclass novel inherits everything from book. It inherits all its variables and all its functions. And so even though it didn't decide to override one of them, the prettyprint method, it should still be there. It'll just be the default one that's available. And indeed, that's what happens. Okay. So this is where, I mean, things become really nice in a sense, where inheritance becomes really nice, because it's what it does the opposite of making you copy a lot of code. It can actually prevent you from duplicating a lot of code. So if book's pretty print method is good enough for almost every subclass of book, then none of those subclasses have to do anything to override it. They just inherit it, and it's completely free. And if one of them, a textbook for example, decides it needs a fancier pretty print method, well, it can override it, and it'll get called when textbooks decide to pretty print themselves. Okay. Okay, so that's a good place to leave off for today.